Now, what is your lateral displacement for a glass slab? Suppose this is a glass slab P, Q, R, S. And AB is the incident ray. If we draw the normal, then this angle is your angle of incidence and it is denoted by your angle I1. This is your air medium and this is your glass medium. So, after entering the incident ray at the point B, the medium will change. That means from air to glass. So, the speed of light in air is maximum and in glass it is less. So, the refracted ray will bend towards the normal. BC is your refracted ray. If we draw the normal here, means at the point C, then again this refracted ray means now we are considering two situations. First case is here when the light or the incident ray travels from air to glass. This angle is your angle of refraction. Suppose this is your R1. Then according to your Snell's law, we can write down refractive index of glass with respect to air. NGA is equal to sin I. Instead of I, we can write down here I1 divided by sin R. R means here R1. That is equal to NG divided by NA. Same thing. NG divided by NA means refractive index in glass medium and NA means refractive index in a glass medium. Or if we cross multiply, then NA sin I1 is equal to NG into sin R1. Suppose this is equation number 1. Now, in second situation means now BC is our incident ray, means this is our first medium which is your glass medium. Then after striking at the point C, it will again refract, but the speed of light in glass is less as compared to your speed of light in air. That's why the refracted ray will bend away from the normal. Clear? Now, this angle is your angle of incidence. Suppose we denote by symbol R2. But this is your incident ray in second situation. And this is your, this ray is called as your emergent ray. And the angle made by the normal and emergent ray is called the angle of emergence, which is denoted by your symbol angle E. Clear? Now, from the second situation, that means refractive index of air with respect to glass, NA G is equal to sine I means angle of incidence, which is equal to your R2 divided by sine R. Sine R means sine E is the angle of emergence. That is equal to, you can write down here, NA divided by N G, refractive index of air medium divided by refractive index of glass medium. Now if you cross multiply, then we can write down NA sine E is equal to NG sine R2. But these two normals are parallel to each other. So this angle and this angle means R1 and R2 are equal to each other. So instead of R2, you can write down R1 also. NA sine E is equal to NG into sine R1. Suppose this is your equation number 2. Now compare equation number 1 and equation number 2. Right hand side of equation number 1 is your NG sine R1 and right side of equation number 2 is also NG sine R1. Means both are equal. So left hand side of both the equations will be equal. That means you can write down NA sine I1 is equal to NA sine E. Or NA will be cancelled. So rest part is your sine I1 is equal to sine E, or you can write down here I1 is equal to E. What is your I1? I1 is the angle of incidence. And what is your E? E means your angle of emergence. That means our conclusion is your angle of incidence is equal to angle of incidence is equal to angle of emergence. Or in other words, you can say these two angles are equal. Means the incident ray and the emergent ray are parallel to each other. Incident ray is your AB is parallel to CM, suppose, is your emergent ray. These 2 points are here very important. AB is parallel to CM. That means in your glass slab, we concluded that the incident ray and the emergent ray are always parallel to each other. So angle of incidence is equal to also your angle of emergence. Now if we extend the incident ray this is your incident ray and this is your emergent ray. If you join the perpendicular distance between these two rays, then this perpendicular distance is called as your lateral displacement or lateral shift. So how can you define here lateral displacement or lateral shift, it is defined as the perpendicular distance between your incident ray and emergent ray. Clear?